So lesson 8 is about equivalent ratios defined through the value of that ratio, and let's remember that to find equivalent ratios, you multiply both numbers by the same factor, which means I can also divide. If I can multiply, we know fact families mean that I can divide by the same divisor. So we're looking for any equivalent ratios here on this section right here. So 1 to 2, how do I get from 1 to 5? Well, that would be 1 times 5 equals 5. So I'd have to multiply the 2 by 5 to get an equivalent ratio. So are these two equivalent? Sure they are. They are both equivalent by times 5. So looking at 6 and 16, those to get from 1 to 6 is times 6, from 2 to 16 is times 8, so this is not equivalent. And 12 to 32 would be times 12, so 2 times 12 would not be 32, and therefore not equivalent. However, I can use a different color here because I don't know if anybody noticed this. Let me erase some of this. It looks like 6/16 and 12/32, 12 to 32 are equivalent ratios. So 1 to 2 is equivalent with 5 to 10, and 6 to 16 is equivalent with 12 to 32, because from 6 to 12, that's times 2, and 16 to 32 is times 2. Now, the next section may seem a little bit confusing the way they word it, and can be, but it's basically saying to write it as a fraction, because that would be the value of the ratio as compared to a whole. And that's what we were talking about earlier in lesson 7, that ratios can be fractions as well. But then it says to rewrite the fraction using the largest possible unit. What we're actually looking to do here is bring it into simplest terms. So that might help, all right? Largest possible unit would be simplest terms. And if you remember, simplest terms is to divide it as much as possible until you can no longer divide both numbers again. So the value of this one is 1/2, and you don't have to do anything with that. But 5/10 would also be 1/2 because it is equivalent to the 1/2 before. And I can divide 5 by 5 and divide 10 by 5 to get 1/2. So 6/16 can already be divided. I can already make this smaller. If I divide both of these by 2, I get 3/8. And that is as simple as it gets. So the value of this one is 3/8. And since this was equivalent to that one, it is also 3/8. So what do you notice about the equivalent ratios? Now's a good time to pause the video and talk about that. For those who don't want, who aren't sure, or maybe you are sure to check, you notice that if they're equivalent ratios, they're going to always deduce to the same simplest terms, because all of them can be divided by the same divisors, just as they could have been multiplied by the same factors. So in exercise 2, what they want you to do is understand that all these fancy letters, what it's saying is that as long as the bottom number isn't a 0, when you transfer a ratio into a fraction, and then you do that again to its equivalent ratio, then the fractions will also be equal. Their values are the same. So since these are equivalent ratios, when I transfer them into fractions and bring them to simplest terms, I will get the same simplest terms. Therefore, their value is equivalent. Over here, 1/2 and 5/10, they are equivalent ratios, so their value will simplify to the same terms. And that's all this is saying. So for exercise 2, the can you provide counterexamples, I'd like for you to try this out. And if you have any questions about it, bring it to class to me or ask a teacher, and then we will explain it. But I'm not going to go over that on the video because it would kind of ruin the fun of the activity. This question talks about a race with cycling and running, and since there's it's a longer cycling leg than running, he just rides his bike more than he runs when he trains. So for every 4 miles that he runs, he rides his bike for 14 miles. And it wants us to find the ratio and then find its value. So what I did was I wrote the ratio of 4 to 14, and that stands for how many miles he runs to how many miles he bikes. And that was given to us in the problem right there. So hopefully you're recognizing that the problem usually gives you what you need as long as you have your problem-solving skills with you. So the equivalence and its value would be 4/14. So we're just writing top number The first number on top, second number on the bottom, and it is 4/14. Now what some of you might notice is, again, I can simplify this, so I always like to do that. Anytime I have fractions, I like to simplify them and bring it down to simplest terms. So I can divide both of those by 2, and that's going to equal 2/7. So this is going to be my simplest term value for my original ratio. So let's look down here. It says, when Chavion completed all of his training for the duathlon, the ratio of total number of miles he ran to total number of miles he cycled was 80 to 280. Is this consistent with Travion's training schedule? Explain why or why not. So the first method I'll go over is this one right here. And everybody knows what this is. This is a tape diagram. Very good. And you'll notice I put the 2 for running on top of 7 on the bottom using my original equivalent ratio or fraction. Sorry, this is the fraction. But I took the 4/14 and divided each by 2 to get me an easier tape diagram to draw. And now I'm saying that this has to be 80 and that this total has to be 280 according to the question. And again, the question gives us what we need, so we need to keep going from there. If 2 boxes, 1, 2, is equivalent to 80, then how much must go in each box? You are correct. 40. Which means every other box has to be 40. And as you put that in, you can then come and check and see, is it going to equal 280? So I take the 40 7 times. 4 times 7 is 28. Put the 0 on the end. Yes, it is going to be 280. So now you can answer the question that it is... It is consistent with his training because it is an equivalent ratio. So I would have to write that 80 to 280, sorry, is the same as 2 to 7 or 4 to 14. They are related by growing at the same rate of change, and therefore they have the same value. And this last problem is actually really easy because of all the work we've already done. It said he ran 4 miles and cycled 7, and it asks if that's equivalent or not. Well, no, I mean, it can't be, because if you just reason with what we had up here, that if I ran 4, I'd have to bike 14. And this could be the ratio of 2 to 7 by dividing each by 2. So if this was 7, this would have to be 2. And we know that's not true. So I would explain that here in clear words.